Alright, we're going to talk about density, and density is the, just go up. Density is the mass per unit volume, so basically it's how much mass you have in a given volume of a particular object. So basically if you want to find, sorry, if you want to find the density of an object, you use this equation right here, which just stands for the density of an object equals the mass of an object over the volume of an object. You can see that okay? And so your units then therefore can be, since mass is measured in grams, it can be grams. Volume can be milliliters if you're using a liquid, or if you saw in your section 2 notes, volume can also be a cube, so it could be like centimeters by centimeters by centimeters, so it could be cubic centimeters. And remember that 1 milliliter is equivalent to 1 centimeter cubed. So those two units can actually be interchangeable, meaning that these two units are exactly the same. Keep in mind that this is a derived unit, meaning that it's a combination of units. And so density, the SI unit for density would actually be kilograms per meters cubed, from kilograms from the SI unit for mass and meters cubed from the SI unit for length. And so not super important, but I just want to kind of bring that up and note that this is something called a derived unit, meaning that it's a combination of units. Alright, so let's do some examples. Oops. Oops. Okay. Oops. I'm on example 2. I need example 1. There we go. So, what is the mass of an object? The mass of an object is 5 grams. The volume of the object is 2.5 centimeters. What's the density? So we know density. So density is m over v. So we have that 5 grams there. So grams is a mass, so I have 5.00. And remember, we need all these for sig figs. And 2.5. So 2.5 centimeters cubed is the volume. So that's going to go down here. And so we want to find D, which is good because that's the only thing we do not have. So you're just going to divide the two. 5 divided by 2.5. Easy enough, right? That's 2. So your density is 2. Sig figs would be 3 on top, 2 on bottom, so you need 2. So you'd have to put 2.0 after it. Label. Now, they gave you grams. They gave you centimeters, which means this is grams. This is centimeters cubed. So look what your label is. That's what you would label it. Okay. Let's try another one. Alright, so the mass of an object is 9.9 grams, the volume of an object is 10 centimeters cubed. What's the density? And then they want you to use a chart on table 19. Now, rather on a test or a quiz or something, I might give you a chart. In this case, we would look up on this chart. So 9.9, so D equals M over V. 9.9 grams, so that's your mass. 10 centimeters cubed. That's your volume. Solve for D. So 9.9 divided by 10. Easy enough, right? It's just move the decimal over 1.99. 2 on top, 3 on bottom, so your answer could have 2, so we're good. So our density is 0.99. Now we would go to the chart on page 19 of our books or whatever it may be and be able to look up what the identity of that actual object is. I believe in this case, because I don't have the chart in front of me, of course, 0.99 is usually about water. So I'm guessing, unless there's something else close in that chart, it's probably water. I could be wrong, though, because, like I said, I don't have the chart in front of me. That's always good, right? Way to be prepared. But just go to the chart, look up and see what object is closest to 0.99. Oh, and I forgot to label it, didn't I? Again, so that would be actually 0.99 grams per centimeters cubed. All right, last one. Density, example 3. An object has a density of 4.5 grams per milliliter. It is put into a graduated cylinder containing 5 milliliters of water, and the water raises 55 milliliters. What's the mass of the object? Now, this happens a lot where you have a weird-shaped object where it's a solid, but so you can't use a graduated cylinder to measure it because it's not a liquid, and it's not a perfectly shaped solid, so you can't take a ruler and measure each side. So what do? You use water displacement to actually measure the volume of it. So basically the thought process is that you have, like a graduated cylinder of water. You take that object and you drop it in. And they're saying in this case that it started with 5 milliliters. When they drop the object in, though, it raised to 55 milliliters. So if you think logically about it, the only difference between start and stop is the object. So that means that that object, therefore, then must have a volume of 50 milliliters because that's how much it took to raise the water. So that's called water displacement. It's a way of finding the volume of objects that you can't technically measure or, with like graduated cylinders or rulers or things. So we have our volume there. Then we have D equals M over V. And so they gave us the D in this case because they want us to actually, in this one we're finding something different even. We're finding the mass. So our density is 4.5. We don't know the M, so we're going to find M. And then our volume we said was 50. So in this case, all you need to do is multiply the top and the bottom. If you're finding mass, it's a multiplication problem. So just take your 50, multiply it by 4.5. That's 225. 225 mass is in grams. Okay. But that's the non-sig fig answer. The 50 only has one sig fig. So we would have to round that to what, 200 grams? 200 grams would be the actual correct answer. Okay, and so that's pretty much density. There's nothing else to tell you about it, so make sure you practice, and we'll talk to you later.